let's set up something about this this situation, shall we? Okay, mountain. Let's call it a kilometer high, because that's the hugest tank in all existence. And let's call it 2 kilometers away. Okay, so suppose we have a target set up on the top of the mountain. Okay, what's a target look like? It's,
I can take it.
there we go. There's my target. Okay, and we want to hit the target, and it's that kind of distance away. Now, what I'm going to make this is a question about varying the angle of inclination. Okay, so I mean this is pretty typical that like if it's a tank, they don't say like let's fire it like a little bit hard or really hard. How fast it fires is generally fixed. Okay, so let's call that outward velocity. Let's call it say 200 meters per second. Okay, but what you can change quite easily is where you actually are pointing as you fire. Okay, and we want to hit right on the target, and that's how far away it is. Okay, so let's have a few questions here. Number one, what angle should I fire at? Okay, once you work out the angle, what's going to be the flight time? How long's the it's a tank? How long's the shell going to be in the air? What's the flight time? Okay, and lastly, can we work out impact speed and impact angle? Okay, very CSI. Trying to work out.
Enhance.
Yeah, that's right. If only we could do that, you know, the zoom in thing. Impact angle and velocity. Okay, so we good to go? Now remember I told you that we always start with these two equations from acceleration, and then we're going to integrate up as we go. Okay, so let's start with just the horizontal, I guess. So begin by saying, I'll do it up here, down here, so I have two columns. X double dot's equal to 0. Okay, so if I integrate once, I'm going to get x dot. Okay, so if you're integrating 0, what do you get? You get a constant. Now, if you've had a look at some of the examples, which most of you have not, you can see I'm going to integrate many times, so I'm going to have many different constants. Okay, so I better call it something better than c. I'll call it c1. That's a vast improvement, isn't it? Now, x dot is equal to c1. I've got to work out what this constant is before I go any further. So how do I do that? Okay, so I'm going to need to know when t equals 0. I'm going to need to know a few things, yeah? So, for instance, I should probably set a location for this. Now, what do you think would be a nice definition for the tank?
North Korea.
I was more referring to an answer like, say, the origin. North Korea will be fine. Let North Korea be. Okay, great. That's going to be the greatest question ever. I don't know, it's an artillery exercise. Okay, we're starting at the origin in North Korea. Now we also need to know about where it's going, right? Because I'm after velocity, right? So I need some kind of initial condition that's connected to that, right? So if I want x dot, I'm going to need to take, this information, and I'm going to have to resolve the velocities, right? Yeah? So how am I going to do this? How do I resolve velocities again? So I can draw my triangle, right? He is firing upwards. You guys might have had a look at questions where you just fire horizontally, something like that. Now, I know what V is. That's 200. Okay? But I don't know what the angle is, right? In fact, that's what I'm trying to work out, yeah? So I'm going to have to make that my variable, okay? Let's call it alpha. So therefore, on the basis of this, go back to your equations for x dot and y dot. X dot is V cos alpha, right? By the way, if you have trouble remembering which one's which, it's just like on the unit circle, right? So it goes alphabetically. X goes with C for cos, and Y goes with S for sine, because it's in order, okay? I know what V is, and I don't know what my angle is, so I just got to leave it like that, okay? In the same way, I can get my vertical velocity, so that's going to be 200 sine alpha. Okay, so far so good. So let's use this and bring it over here. X dot equals C1. So when t equals 0, okay, I know what the velocity is equal to, right? Okay, so therefore, C1, when I substitute this in, right, I'm going to get 200 cos alpha because there's nothing else in the equation, right? So there's my x dot. It's actually equal to that at that point. So I'm going to integrate one more time to land on x, okay? So if I integrate 200 cos alpha, that's just a constant, right? So when I integrate it, I should get 200 cos alpha times t, right? So because that cos function's in there, I'm going to actually stick the t in the middle. It just looks a little bit neater so I don't confuse the alpha and the t. Now, I integrate it again, so I've got another constant. I really should have said, it's a bit of a pain because you've got to do it so many times, but got to be neat. How do I work out this constant? Well, again, I've got my initial conditions, right? Namely that we specified the position of where it is, okay? So I'm going to sub that in to my equation. So t equals 0, and x is also equal to 0, right? So you can see your constant in this case is going to be just 0. Everything disappears, okay? Using your initial conditions. So therefore, I now have my displacement time equation. Okay, happy with that? Let's rinse and repeat and do it for vertical velocity, okay? So, the acceleration here. What's the acceleration? Now, I was a bit naughty. I didn't say what, I didn't define gravity as either 10 or 9.8. Let's go with 10. That'll make our numbers neater. So therefore, this is where I'm starting. There's my acceleration, okay? So I integrate up. That'll give me y dot. Yet another constant, okay? And sure enough, I take my value here from when I resolve the velocities, pop it in, and you're going to get that as your third constant, okay? So that's just 200 sine alpha, okay? So, substitute that in, which will let me integrate again. This time when I integrate it, because I've actually got something here, 10t turns into... Yeah. And because gravity tends to be either 10 or 9.8, you'll see this minus 5t squared a lot, or minus 4.9t squared. Plus my fourth constant. Woohoo! Okay. Constants coming out of your ears. Thankfully, because we chose kind of nice numbers, right? This constant also will be 0, right? So after you've worked that out, there's your displacement equation for y.